around so much. But I do. Okay, I'm gonna go ahead and get started talking about the stack. Ooh, that's a little loud. I'll turn it down a little more. Alright, that's fine. But first I'm gonna do something that I just thought of after I went live. I'm gonna move this around because I'm gonna try to put the chat on here. By try, I mean succeed, of course. That one. Perfect. Oh, man. I have a buddy.
I have a question.
I just started streaming. What's your question?
How thorough do you think Valve's lawyers are?
Valve's lawyers?
Yeah, hold on.
Why?
I'll show you.
Alright, well, maybe later, because right now,
God damn it.
I'm streaming programming. You'll learn something.
Oh, you're a noob. I don't have time to stream programming.
Huh?
I don't have time for this.
What do you mean you have time for this?
Ain't nobody got time for this?
I got time for this. Other people got time for this.
Nobody got time for this?
One other thing I just thought of, I should probably turn off my heater because it's loud. 1 second, guys.
You're probably good. I can't hear anything.
Sorry. Okay, I'm talking about the stack today. This might be a pretty advanced concept for you, my friend, because you haven't watched my other videos.
God.
Chat's a little small.
Let me actually go to your chat.
It's whatever. People usually trickle in a little late. I usually start at 6:30 on the weekdays. How many people are actually here right now? 3? I think Vetch is like permanently in my channel, even when he's not home.
Is hilarious.
Yeah, I know, right?
Yeah, he's always in mine too, even when I'm not streaming.
Alright, well anyway, I'm going to talk about the stack. Are you on my stream now?
Yeah. But it's paused or something.
It's paused.
Oh no, let me hit play. I don't know what's going on here. Oh, it's got a little... Oh, do you have like a slideshow up on your
Yeah,
screen?
there's a slideshow. I'm on the
Okay,
first page. Oh, the chat's... I guess it's big enough. I can't really make it bigger.
I'll be like dancing in and out of it. I'm making this movie.
Yeah, that's fine. But as long as you're listening, it's fine. Alright, so... Through the past couple of videos, we've learned about how to write some simple Java stuff. And today what I'm going to be talking about pertains to how methods work. This is a bonus video. You don't need to know this, but it is very interesting. And it'll give you a better understanding of how computers work in general. So, I'm going to go to my next slide. How do methods know where to return to? So we write a method, and we call the method, and it does some stuff, whatever we want it to do. And then when the method's over, we go back to the code that called it. How does this happen? How does your computer know where it left off? It knows because there's this thing in every computer called the stack. It's not a physical thing. It's in software. It's in the software of your CPU and your memory kind of working together. And I'm going to show you how it works. But first, before I show you what the stack looks like, I'm going to give you a very naive idea of what the stack is. So here's some pretty basic code. Pretty easy to understand. The P in that last public is capitalized because autocorrect, but that's okay. So we've got our main method, which is where our code's going to start. I wonder if, yeah, they can see the mouse. Okay. We're going to call do nothing. It's going to go to this method, do nothing. It's just going to return. This method does nothing. Then it's going to go to the next method, which is do something. It's going to pass in a 3. So we're going to jump down here. We've got a 3. N equals n times 2, and we return n. So it's going to double whatever we send in. That's all the code that we're going to look at. So let's dive in. Here's a very naive idea of what the stack is. So we start up here, and right now our stack contains the main method. That's down here in the bottom right. Okay, so we run that line of code. What's it going to do? It's going to jump to the do nothing method. Now our stack looks like this. We've got main on the bottom of the stack, and we've put the call to do nothing on top of it. So then we do whatever's in do nothing. In this case, it's just going to return. So we jump out of do nothing. It's no longer on the stack. Then we go to our next line. Oh crap, what slide am I on? That one. We go to our next line, do something, which of course is going to call another method, the do something method. So now we're inside the do something method, and our stack looks like main method, Do something method. What do you want? Oh, okay. That was my Skype. So we're in the do something method. We're going to run the code. So n equals n times 2. We're going to return n. We jump out of do something. That's the naive view, and then our program ends because there's nothing else. We jump out of this. It goes to the end of the main method. So there's nothing else to do. So that's the very naive view of how the stack works. Whenever you call a method, that method goes on top of the stack. And whenever you return out of the method, you take that method off the top of the stack. So it's a last in, first out stack. That's what a stack is. Okay, last in, first out. The last thing you put in is the first thing to go away. Alright? So the stack can pile up more than one method at a time. So that's a very naive view, and I'm going to show you a more detailed view of what's actually happening. So I've numbered these line numbers. Okay, so there's 1, 2, 3, 4, 5, and 6. These are the lines of code that actually do something. And up here in the top right, I have what's called a stack pointer. Your CPU has these things on it called registers. Think of them as very tiny pieces of memory. They're called registers. Each register can store a little bit of data, just a little bit. If you have a 32-bit processor, it can store 32 bits of data in each register. A 64-bit CPU can store 64 bits in each register. That's not a lot of space. The maximum number for a 32-bit the maximum value for a 32-bit integer, including negatives, is like 2 million. Not that big. Or 2 billion. I never remember. Anyway. Let me actually wait. 1, 2, 3, 4, 5, 6, 7, 8, 16, 65. Yeah, it's... Okay, yeah, I was right. But anyway, I had to count it. The stack pointer is one of these registers. There are many registers. Some of them are used for temporary data storage as you're doing calculations. Some of them are used for other things. Stacks for days. Some of them are used for other things. The stack pointer is used for other things. The stack pointer actually keeps track of the location of the code that the current method will return to. Got that? The stack pointer points to a place on the stack that contains think of it as the line number that it's going to return to, the line number that it was called from. That's not 100% technically correct, but I want you to think of it like that. Because if I wanted to explain it technically, it would take forever. It's like you have to take a whole class to understand everything that goes on the stack. But think of the stack pointer as we've been making Java objects and we've been making variables. The stack pointer is a variable that stores the piece of code that called the method that's currently running. Okay, that's what the stack pointer does. So we start in our main method. Our stack pointer is empty because we haven't called a method yet. Okay? Somewhere in the JVM it called the main method, but we'll forget about that. So here's the stack on the bottom. It's just main, that's the method we're in. And here's the stack pointer, which is currently empty. So we're going to run ahead once, and it's going to call do nothing. So it calls do nothing. This is line 1. The stack pointer is going to store. I'm going to return to line 1 when I'm done with this method. That's what the stack pointer is going to store. It's going to store the number 1. Then we're going to go into that method. So here's our stack. We've added do nothing to our stack. The stack pointer is actually on the stack, by the way, but this is also not a technically correct representation. Okay, the stack would be like inside this do nothing. There'd be other stuff in here, but this is, again, a very naive view. So then we're gonna just call this code right here. I've changed the code. It doesn't say return anymore. It says jump to stack pointer. In this case, the stack pointer is 1, so we're gonna jump back to line 1. So we jump back to line 1. We've already run that code, so we'll go to the next line, which is do something. Okay, but we're not actually gonna do that right away, I don't think. It depends what I put in here. Oh yeah, we are. I did this later. Alright, so we're gonna call do something. The stack pointer is gonna contain the number 2, because we called it from line 2. And then do something is on the stack. And then we run some code. We run that, n equals n times 2. We push n, which means it's going to go somewhere. We're going to store the return value. And then jump to stack pointer, which is 2, so we're going to jump back to the end of line 2. and then that's the end of our program. Okay, so the stack pointer is a variable on the stack. I'll be a slightly more technically accurate. Things on the stack are, if you have a 32-bit processor, everything on the stack is a 32-bit value. One of those values, let's say we'll go back a little bit. We'll go back to this line of code right here, the first line. When we're calling this method, what we're actually doing is we're putting this value, the number 1, onto the stack. So rather than looking like this, it would actually look like this. This would be a 1, and our stack pointer would be pointing to this location on the stack. That's what's actually happening. The stack pointer is located on your CPU because it's a register. It's pointing to some place in memory where the stack is. Particularly, it's pointing to this value, whatever got pushed onto the stack right before the method was called. Okay, I'm going to leave that slide like that because I'm not coming back to it. So when we pop it off the stack pointer's not pointing to anything anymore right now because there was no code. And then we're going to move on to the do something. So now the stack pointer is pointing to this thing on the stack, which is 2. That's what's actually happening. So the stack pointer is in your CPU. It's not in memory. It's in your CPU. It's a register. The stack, these two things are in memory. So the stack pointer is a variable on your CPU, on your processor, that's pointing to a place in memory. And that place in memory has the code that it's going to return to. I keep repeating this because this is really confusing for those who are new, and even if you're not so new, assembly is really confusing. So that's why I'm repeating it a lot. So then, we're going through this method, and our stack pointer is still pointing to the same place. We're still going to return to the same code. And then when we exit this method, the do something method, then our stack pointer is not going to be pointing to anything because we haven't called a function. We exited out of every function that we have called. Now I have one more slide here that shows you the more complicated view. This is much more close to what assembly actually looks like. So if you don't want to see any assembly, close your eyes or skip the next 2 minutes of the video. Here we go. Bam! This is what assembly kind of sort of looks like. I don't think this will actually compile. I've kind of shorthanded it, and to be honest, I half-assed it because I didn't really study before this show. It's been a few years since I've done assembly, right? But this is the gist of it. So you remember the code. We're gonna do nothing. The do nothing call is right here. We're gonna push this onto the stack pointer. Okay, this means push. That means we're gonna put something on the stack. The thing we're gonna put on the stack is 1. Okay, then we're gonna go over here. We're gonna jump back to the stack pointer. Oh no, sorry. We're gonna jump into which one is it? This method. We're jumping into this method actually. Can't just be showing assembly to people. I warned them. I said if you don't want to see assembly, just wait 2 minutes. So this jump right here jumps into the do nothing method. And the do nothing method is at 4, so we're going to go to line 4. And the do nothing, all it does is returns. Oops, what did I do? This is wrong. It should be 5. That's a 5. I changed these numbers like 8 times because I made so many mistakes. But we're actually going to jump to this line of code. This is the return. Not enough warning. I'm sorry. I'm sorry. I'm trying not to break your brain. So line 5 is the do nothing method because it does nothing. It just returns back to where we were. Why is this stuff here? Whatever. Maybe if I go back a slide, it'll fix itself. Alright. So line 5 is our do nothing method. These slides are not bad, man. Did you see what David Kim's slide looks like? There was like one slide inside of another slide, but they were like overlaid kinda, so you couldn't see one of them. It was real bad. But anyway, line 5 is it corresponds to this line right here. Return to where the stack pointer was. So jump to, and the stack pointer is our argument. We're going to jump back to 1. Okay, then we're going to go to the next line, which is push 3. So this is what's happening actually here in this parameter. When you call a method that has parameters, you're actually pushing the parameters onto the stack first. Proceeds to create a website so I don't have to use slides. Hey man, I didn't want to make a website. I wanted to use PowerPoint. It's fine. At least I didn't use MS Paint. Although, MS Paint is pretty godly, I will say. MS Paint is the Photoshop of Notepad. No, that didn't make sense, but it did, because it's MS Paint. Alright, but this, when you push parameters onto the stack, or sorry, when you call a method with parameters, you actually push the parameters onto the stack before you call the method. And here's why. So we've, here's our do something is push 3 onto the stack, then we're going to jump to line 6. You thought I did what? Made a website or used MS Paint? Stop making fun of me. Oh, it's too good. I wish I could make the chat a little bigger. You know what? You know what? This guy is going to go over here, that guy's going to go over there. You know, we're just going to get rid of the border too, because this chat's pretty good. You guys are pretty awesome. I'm just going to make this big. It's okay that it's not see-through because... Oh, I forgot to do the chroma key, because it was on a black background anyway. Bam. That's not good enough. Shazam. Shablam. That should be an 80. Okay. Alright, we're see-through, guys. We're completely transparent now. As I was saying, but now I'm... okay, we push 3... Why does it do this black stuff? We push 3 onto the stack. Yeah, color key, chroma key, same thing. And then we call jump to line 6. That's this one. Jump to line 6. Alright? I'm using normal OBS. Is there... I don't know the difference. I've never heard of OBS multi-platform. I'm just using OBS 0.656 beta. Anyway, we're jumping to line 6, and that's here. So what we're going to do, this line 6 is really complicated, so I'm going to walk through it very slowly. Move, MOV, this is the move function in assembly. We're going to take some data from usually memory, and we're going to put it somewhere else. But in this case, we're actually moving from one register to another. Oh no, sorry, we are moving to memory. SP-1 is the stack pointer. Remember, the stack pointer points to where the return, the code to return to is on the stack. So stack pointer -1 is going to be your first parameter. Remember, because you push parameters before you call the method. So you're actually putting a parameter on the stack, and then you're putting the stack, you know, where the code is going to return on the stack on top of it. So when you do stack pointer -1, you're getting the last parameter for that method. So that's what we're doing. We're moving our parameter to, and this EAX, this is another register. It could be any other register, but EAX is the most commonly used one, so that's what I put. Then we're going to call this multiply method on EAX, and we're going to multiply by 2. That's pretty easy. That's what line 7 does. So now we're in here. We're in the... Whoops. Oh, crap. Oh, God. I've ruined the world. Alright, so we're doing the n equals n times 2. This is what lines 6 and 7 and 8 do. So 7 actually does the multiply, and this 8 move EAX to stack pointer -1, that just puts it back where it was. Okay, so we've loaded our parameter, we've doubled it, and then we've saved it back to where it was. That's lines 6, 7, and 8. Okay, line 9, we're moving the stack pointer into a different register, EDX, because I didn't remember which register return values go in. I'm sure there is one. It's been several years since I've done assembly. But we need to return the value, so we need to store it somewhere before we leave this method, because otherwise, you know, we lose it. And so we've stored our return value, and then this jump actually returns it. We're jumping back to the stack pointer, which was, the last time we pushed to the stack pointer was, where are we? I didn't do the push for the other stack pointer, but we're going to jump back to line 4, which is the end of our program. So this is the assembly, the pseudo assembly version for this, oh, not that code, for this code. And that's pretty much all I wanted to talk about. I think that knowing the stack is not necessary. Most people won't use it. If you do a lot of hacking, you will use it. Because sometimes all you have access to is the raw, you know, the raw code for whatever it is you're hacking, for old Super Nintendo games or whatever it is. And there are a lot of scripting engines that use assembly too, like all the Final Fantasy games use assembly to do cutscenes and stuff. So this is, I hope if it was at least a little bit understandable, you have a pretty good idea now, at least how methods know where to go back to. When you call a method, all you're doing is you're putting the location of your code onto the stack for it to remember. And then when you return from that method, it just gets that memory address and goes back to, where it was. It goes back to the code that called it. That's really most of what the stack is about, is storing where you were so you can run other code and then returning to where you were. That's it. And that's how computers do methods, functions, subroutines, whatever you want to call them. That's how computers do pretty much everything. You need the stack. Oh yes, I know the CBR plugin. I haven't gotten it, but I probably will eventually. I don't know what I'll get it for, but it seems cool. So yeah, this is a little bit closer to assembly. This is kind of actually what the code is doing if you could write this in Java. Anytime you call a method, you're storing what line of code you're on, more or less. Then you're jumping to whatever method you're calling. And in that return statement, you're just jumping back. That's all it is. That's pretty much the stack in a nutshell. Any questions? Again, this is a pretty advanced topic, which is why most of it was kind of vague and it was really quick. If you go through computer science, what was I going to say? If you go through a computer science program in college, university, you will probably take a class where you will write assembly. I had to. Everyone at my university in that thing had to. What is it, Verdant? I can't wait. Why is LibreOffice so bad? I'm using OpenOffice. I don't know. You asked me about this before. I don't know why LibreOffice is so bad. I think you showed it to me, and I was like, this is bad. Is that what I said? Verbatim? This is bad. It's almost as bad as looking at this. Dun dun dun! Assembly way too confusing. And anyway, I work with assembly to mod Final Fantasy VIII, and I still get confused. Assembly is not something that's easy to understand for anybody, because it's meant for computers, not for people. Particularly, every line of assembly does a very, 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 very tiny thing. You guys are such trolls. Oh boy. Expletives and Blizzard references involved in LibreOffice. Oh man. All I remember about LibreOffice is you asked me about it, and I looked at their website, and I said, I have OpenOffice. I'm pretty sure that's all I remember. See, watch, this is, I'm going to mess up my thing, but it's the end of the video anyway. This is OpenOffice. See right there? OpenOffice. I have destroyed the illusion. The PowerPoint wasn't actually running, it was just in a window. Oh no. That was really short. It was like 22, 23 minutes. Everything you know is a lie. Yeah. Sorry. Yeah, my PowerPoints, I don't actually launch them because... Wait, watch what happens if I launch them. Check this out. This is pretty awesome. Watch this. Bam! Uh-oh. Oh, snap. I can't even, like, see... Wait. Oh, no. What did I do? Go to slide 8. This is what my PowerPoint looks like. It's like a big white screen for no reason. I have destroyed Christmas for Verdant and Gamers Action. I have destroyed Christmas and Hanukkah and Kwanzaa and all that stuff. Whatever you believe in, I have shattered it. because my PowerPoint is fake. Woo. I mean, if you really want me to shatter reality, I can just do this. Woo! Okay, this is real dumb. What are we even doing here? So anyway, wait, I have an idea. Check this out. This is cool. Make sure I don't accidentally hit the X button. So this right here that we're looking at, this is actually a pretty good representation of the stack, because this outer window that you see on my cursor, all 20 of them, this outer window would be like the lowest level of the stack, and then the next one would be, you know, the next one up, so we're calling a new method. And then the next one is like calling a new method, and if we pop some methods, we just move this thing sideways, so we only have 2. And if we want to add a method, we move it to the left a little bit. Now we've got 3 methods on the stack. This is so stupid. And then if you're like Blizzard or Riot Games, then you might have a stack that looks like this because there's an infinite loop in your code. Any other questions? It's cool because there's a delay too, like my mouse. There's a slight delay on each frame. A 1 frame delay as I rotate. You can see it propagating backwards. I spent like an hour preparing the slides, and then we ended up just looking through an infinite series of windows. When does OBS start glitching through your monitor? Maybe if I make it bigger. Let's see. I think if I do this, can I get... Let's see, that gets less windows. This gets way more... I'm going to do this. Here we go. Oh, it's already starting to glitch for me. That's weird. But it's also so cool. I don't even know what this looks like on stream. I don't know how laggy it is. I imagine it's pretty laggy. We're running through like an infinite curvy maze in Doom right now. That's what this looks like to me. Running through the infinite maze of Doom. Okay, that's enough of that. I'm gonna move this guy over here. I don't want to give my audience any seizures tonight. Maybe tomorrow night. Alright, well that's all I had, and you guys don't seem to have any questions. Probably because your brain melted when I showed you the assembly. So anyway, I'm just gonna stop, I guess. I didn't actually have anything else prepared for tonight. I wish I did, but work was pretty busy. I couldn't think about home. I'm sorry. People have suggested doing community projects, and I think that'd be really cool, but I have no ideas for what we would make. Alright, well, good night everybody, or good morning if you're in Europe, or good afternoon if you're in Australia.